Recording. Okay, good evening, everybody. So let us start our lecture tonight. Let us see our schedule. So according to our schedule, we are on the halfway. So we have all of the foundational features of object-oriented programming: class, object, inheritance, polymorphism, abstract class, interface. We discuss GUI programming and string operation, reference parameter. And from tonight, we will start linked list. Actually, linked list, tag, QE, okay, and BST. These are the foundational concept of data structure. We will cover only foundation and basic, how to create a link, but you will know in depth in 13 data structure course. But for object-oriented programming and programming perspective, there are two, maybe only two. Yeah, two topics, chapters left: exception handling and file and IO operations. Once you know this, then we will cover the programming foundation and the task. So hopefully before Thanksgiving break, within the next maybe 5 weeks, we will cover almost everything. Okay, so let us start with linked list today. Okay, so before I go to our slide, you see the linked list, the word over here. It says the title over here, linked list, and it is a plural sentence, right? If we hear this word, we may guess something. There will be list. A list is a kind of set, or in some language like Python is called list. Okay. And in other languages it is called, the list also, it is called an array. There are similarities between an array and a list. Okay, a list is a kind of set. There is a difference between a set and a list. Okay, anyone know the difference between a set and a list? Set cannot contain duplicate values, one value at a time. Okay, but a list can contain same value again and again and again, more than one time. That is the basic difference. Okay, and you will see that by the time we will discuss linked list, tag, and QE, you will see that in modern programming languages there are built-in classes in order to implement linked list, tag, QE. But sometimes we will use the built-in classes to create a linked list or list, or for instance an array list. It is easy to use built-in classes, but instead of using built-in classes, we will learn how to create our own data structure, like as a linked list, how to create a linked list, how to create a stack, how to create a QE, and how to insert data in a linked list, and how to delete data from a linked list, and how to extract or search data from a list. Okay, so the word, it says linked list. That means there will be linked, there will be a list, and the elements of the list will be together. Okay. So let me go to our official slides. So if we go to resource page and slide repository, and function stack. Okay, linked list, lecture 14 lecture today. Okay, the title of the chapter is linked list. There will be a list. Elements of the list will be linked together. Okay. So a linked list is a dynamic data structure. Yeah. So in programming language, we know a static data structure, like for instance, an array. An array is a static data structure. So with a static data structure, there is a limitation that, for instance, when we define an array, we have to assign its value as its size with a fixed number. Okay, and once we declare an array with its fixed length, while our program is running, we cannot change the length of the array. Array size will. Okay, so there is the possibility that if I have unexpectedly more data that I thought about to store in my array, I would be out of space. Okay, or it may happen reversely that if I declare a large array, but I have only a few data items, there will be misuse of my memory. So in order to solve that kind of problem, array, the concept of dynamic array, dynamic list or dynamic data structure come in Excel. So in the dynamic data structure can grow and shrink at execution time. That means while our program runs, the dynamic data structure size can grow or shrink when we delete some elements. Okay. So a linked list is a linear collection, is a linear data structure. Okay. So that is a sequence like a chain. Okay, we know that a chain, for instance, when we know the chain, each of the ring is linked with another ring, right? So here, for instance, in real life, when you say ring, not this ring, chain. If I search for a chain maybe. Okay, that's good. You see that this is a regular chain. So in this chain, this kind of chain, I'm sorry. I just did but like this kind of chain or this kind of chain, okay? So each of this ring, okay, I'm telling you this is a ring, okay, or circular, these are is same because for a chain we say, in our language we say this is a ring, okay? So each of this ring is connected with each other, right? So for instance, this ring, if this ring is the top ring, it has only behind connection of the behind ring, and the middle rings have two nodes, two other rings connected. Okay, so like for instance, think about that. A linked list is a kind of this kind of chain. Okay. In linked list, each of these we will call this a node. Okay. Connected by reference link. Okay, what is the reference link? We will know this one. Okay, okay, chain together. Okay, a linked list is appropriate when the number of data element is unpredictable. Whenever we do not know ahead of time how many data items I will have to deal with. So what we want to do, we want to create our own list, own data structure that will not misuse any memory location. But what it will do, it will serve our purpose. Whatever variable or whatever data we store in our list, that will be stored, and whenever we delete some items from the memory, then our memory location will be empty automatically. So these will be done dynamically so that we will not misuse memory or we will not run out. So then the two elements, okay, so the main element of a linked list, okay, is a node. So what is a node? A node is a class. So in general, now remember that a node will be a class that will contain at least two things. That will contain two things. A node will contain some data and another node. Okay. Another node is actually, we will call this is a reference to another node. Actually, this is called key. In sometimes we will say key. So what this will do, this node will contain or will know who will be the next node associated with this node. So every node will contain, will have two things, one data item and another item will be node. That node will hold the address of the next node. So you know that how do we access memory location? How do we access elements of an array? By using index, right? For an array, we use index, right? We use indices for index starting from 0. We traverse an array one after another, sequential, or jump in any position. But here, in order to go to in a location, we have to go one by one, since this is a chain and we have to start from one position, the next. In other words, you can remember that a linked list is kind of a stair. So this when you have a stairway, there are some steps, right? In order to go to the upstairs steps, you have to follow the bottom steps. Okay, so the two elements measure a linked. Every node will contain a data, some data. Data can be any type of data. It can be an integer type data. It can hold float or string type data or numeric data or boolean data, or it can store object. Okay, and the important thing that there will be link. Okay, so once we know this, then what we'll be able, to, once we create our dynamic data structure like linked list, we will be able to add some element. So for linked list, there are two words. It's called prepend and append. Append means adding an item at the end of list. Prepend means adding an item on the top. Okay, we will go through this. And then we can also insert in between. Okay, and we can an element, and then we can search and we can sort. These are the operations we will know. So the slides, whatever we have over here, it shows For instance, insertion method. Insertion method is called in order to add some node in a linked list. I want to go through this. I will come back here later, but let me show a live program. So then delete method, and then so we need to give focus. First one, how to create a node. Then once we create some node, okay, then we will be able to connect this node. By the way, is there anyone here still does not know how to get a project from GitHub? Anyone here that need help? Get a project from GitHub? I have my complete project on GitHub. So instead of writing the same problem again and again, I want to from my previous semester. Okay, so if you go to my GitHub account, github.com/my account name is CSITEd experts, and then CSE1322 review Java. This folder should be good one. Okay, this program. Okay, so then source. Let me see. Yeah, I have linked list. Okay. If you clone this project, it will. I have this project here. Let me see. CSE1322. You see linked list. By the way, linked list is, there are two kinds of linked list. It's called singly linked list or doubly linked list. Okay. So now we will start from a singly linked list. Okay. So your name is Michael. You're Michael? What is your name? Yes. You can see from back? Okay. The main element of a linked list, okay, is a node class. Okay, so what as that a node class contains two things, some data and another. Okay, so this node, for instance, data can be any type, integer type or string type or float type or double type. So in order to, let us start with an integer, with both integer type, ID and name, string type. Okay, so if we understand how to insert data, both integer and string type, I think we will be able to do other types. Okay. And this is node next. See the same thing. It is named, and it is actually it is containing itself. Okay. So this next node will refer to the next node in the linked list. Actually, it will hold the reference to the link that was created. So it will, so initially, until we connect to each other, okay, it it will be null by default. Okay, and for this, let us make a constructor. Okay, so we want to add data using a constructor. So what is a constructor? Static. You know, a constructor is a method that has exactly same name of its class name, right? Why a constructor? A constructor is used to instantiate an instance or create an instance of a class. Okay, so let us make this constructor like this way, node, and it will take two integer type, sorry, one integer type id as argument and another string type argument, so for name, and then we are making this dot id equal to id and this dot name equal to name. Understand why do we need to use this keyword? Okay, we are connecting this whatever id we will provide while creating node instance. We want to provide that id value as an id for a node type, and the name or value we provide, we want to provide that name to this name. Since we have exactly same name of our this field name and parameters name, so we need to use this. We use a different name, then we do not need to use this. That will be that case. This will be optional. Okay, that's it. So far everybody understand this? So this is my node class. Everybody understand this? Okay. So every node will contain here data. We have two data elements. One will be integer type id. For instance, we want to give id of a node 1, 2, 3, 4, 5, 6, 7, 7. Like this. Okay. And we want to give name of a node a, b, c, d, e, f, g, h, I, j, something. Okay. And what we want to do, we want to connect every node with each other, not manually. Start from manually. Okay, so if everybody understands from this, we will start from here. So everybody understands this, right? Anyone has any question? Okay. So our purpose is simple. Okay, we will create a node class that will hold data, and this is the maybe the first thing, since we want to link each node element to the next node element. So this is why we need this. Otherwise, I believe except this line, everything is simple and known to us, right? Okay. Now let us forget this. Now we need a main method. So you see my node class. Okay, my node class is done here. My node class is ended here. Okay. For now, let us think that we have only node class for. Okay, node class is this. I have some other elements, display node and node in my node class. Okay, I will tell you why do I need this. Okay, now this is my main class. So my main method, this is my main class. Actually, I put all together in one file. This is why it is lengthy. Okay, so then, how my node class is constructed? It has a constructor that takes two arguments, type integer type argument and a name, string type argument. So how do I create an instance of my node class? So for instance, node n1 equal to new node. This is one for ID, okay, and this is my n1 for name of this node. Okay, so this is first node. I'm telling that, for instance, first node, the name is node object name is n1 and its ID is 1 and its name is n1. Okay, everyone understand this? Similarly, I created two node object into, just for simplicity, let us make it ID equal to and name equal to n2. And the third one, for node 3 object, ID equal to 3 and name equal to n3, and so on. For instance, we have 6 nodes over here. Okay, for instance, let me do something. I want to make it as start it from scratch. Let me think that I want to start it from scratch. I want to delete other stuffs and save it in another file so that you can see all of my course. Okay, whatever I do have, I just created only few node objects. Okay, and how do I display? For instance, if I run this program, it will not display anything, but it will not make an error. The program is so far it is okay. Since there is no printing something, then I need to write some print operation. Okay, for instance, if I want to display n1, what do I need? For instance, one of the things that we need to override the toString method, right? We need to override the method. What the toString method will do? ToString method will usually returns a string type, and whatever we want to do, we are just returning name. It will return. Okay. For instance, let us create another method. This method name, we play display a name or print a name. For instance, what we want to print, very simple, ID and name of the node. Very simple. Okay, ID equal to ID and name equal to name. So this, in addition to our constructor in our node class, I want to just add to these methods so that I can. Okay, so now once we have this method, so then how do I display node A? Sorry, n1. Then I will say n1 let me write it, n1 dot sorry, my computer is slow. Not responding. Okay. So if I click on N1 dot, then I have display a node method. Then I can call it display method. Okay. Then if I run it, then it will display my N1 node. Okay. For my N1 node, I have ID equal to 1 and name equal to N1, right? So this is simple. Anyone has any questions so far? Okay. And I'm sorry. Similarly, I can display N2, N3, N4, and N5. So what it will do, it will display all of my nodes together. Okay, but the limit problem is that these nodes are independent to each other. I have not connected this. Okay, so these nodes are independent to each other. This node is not a linked list yet. Okay, so then what do I need to do? That means this node N1 does not know who is linked to it. Okay, so in order to do it, we need to this each other. So that, for instance, we see that in our node class we have another element that is node, right, named next, right? So we need to use this one in order to connect or hook up the nodes. And how do we do that? Is not complex. We will say n1 dot next. You see the next, it has a node equal to okay, it will do, then n2 will be connected to n1. Similarly, if we say n2 dot next equal to n3, then that means our n1 will be top element and n2 will be the middle element, okay, and n3 will be the last element. Similarly, we can do n3 dot next equal to n4. We can give any order, but let me make it this order so that we can remember that we have this way. Okay, and n4 dot next will be n5, and we have only 6 node. N5 dot next will be n6, and what will be the n6 dot next? I have only 6 node, right? N6 dot next, that is our ending node. Okay, if this will be a dead end. So when you drive somewhere, if there is a dead end, you expect that there should have a sign that dead end, right? My dead end sign over here is null. I'm telling that my n6 is the last node. Okay, and here obviously n1 is my first node, since n1 dot next equal to n2, and n2 dot next equal to n3, and n3 dot next equal to n4, n4 dot next equal to n5, and so on. So our list will be like this: n1 that will be connected to n2, that will be connected to n3, that will be connected to n4, that will be connected to n5, that will be connected to n6. That is done. And n6 will be connected to null. Okay, so this is how my linked list will be created. Okay, now let us check it. So if I print, I have actually code over here. So for instance, here until this, let us come back here. I need to show you something. Here I can display all of this node, but until I write this code, these are not nodes are not linked. So at this point, if I type in this system.out.println n1.next equal to n1.next. For instance, let me think that I do not have this code. Okay? Only I have this. Then it will, since I have not connected this link, so it will not show me anything. It will show me null. Why it is null? Because I have a description over here. By default, when you create a next node, by default it will make null. Yeah? Null until we connect it to the other link. So similarly, if we say n2.next, if we print n2.next, then still this will be null. Next equal to null into, that means I have not connected yet. Okay. Similarly, let me print this. If I all of this, if I print all of this, n1.next, n2.next, so whatever it for me, all this will be null. n1.next equal to null, n2.next equal to null, n3.next equal to null. All of this, that means these nodes are independent. But if I run these codes, that means if I hook this node to each other, now if I run this code here, not here, after I connect this, then it will show me the links. Which node is connected to what? Okay, and by the way, you know that we know that programs code are executed starting from the beginning, from top to down, right? One after another. So this is why I need to move this code after I hook this. Now if I run this, okay, now I got something. It is showing me n1.next equal to n2, n2.next equal to n3, n3.next equal to n4, n4.next equal to n5, n5.next equal to n6, and if I see, we know that what is our last node, n6 in this case, and so if I print n6.next, then n6.next should be what? Null. Yes. Let us see if we get null. So we got this, right? So that means we have created a linked list. Creating a linked list is not too much tough, except that there is a few things. For instance, only one thing I added this one. Otherwise, this constructor is simple, and the display method is simple, and the string override, we need it in order to override display this. Okay, we need this required element. We need to override the toString method. ToString method is actually defined within object class. So we need to define, override it, and everything is simple. Connecting over here. So although this is a simple way, anyone has any questions so far? Okay, although this is a simple way, we will not do this because at least there is one limitation. Did you notice a limitation? That I manually linked the node to each other. This is my manually, I have to link each node to each other, right? I will not do that, okay? What I want to do, I want to create a linked list that whenever I create a node, okay, that will link automatically with the previous node. instead of doing this kind of manual connection, manual linking, we want to make an automatic link. That is our purpose. Okay, we want to learn tonight maybe. Let us try, we can do that. But so far, everybody understand this? Anyone has any questions so far? This is our foundation knowledge. Very basic foundation. We create manually. Not bad, right? So far, it should not be. By the way, from the started from the last, we will not be accepting any pseudocode in future. Our goal is to enforce you program and practicing program. Okay. All our code over here available. Please practice programming. And at the end of the second half of this course, you should be able to write code. In any language, either C# or Java. You can implement same code in C#. Just we need to change few things. Main name in uppercase, and instead of system.out.println, we will use console.writeline. That's it. It will work. Nothing different in C# and Java for this one. There is something different I will discuss. But everybody is good so far, right? Patrick? Good? Anyone has any issue? I need to revisit? Okay. So let us see in the next 10 minutes whatever we can do. So whatever we have done, we have created a node. The node will be same. My node class, this class will be exactly same. I do not need to make any change over here. It is perfect. It is done. My node class is done. My display method is done. Okay. One thing I can do, for instance, instead of displaying a node one by one, I may use another. I want to display all nodes together one time using a loop. Okay. But this is now good. This is now good. So let me emphasize this. This is now okay. Our class is good so far. Okay. Now, instead of doing this kind of manual activities, manual linking, the problem of the manual link is that I have to link this manually. And another problem is that if I delete a node, for instance, if I delete this node, 3, right? There will be disconnection, right? So then if I run this program, I will have some problem. See that next 3 dot node 3 dot next equal to null, because I did not connect node 3, right? So I disable that node 3 connection. Okay, so what we want to do, we want to write a program so that as soon as we create a link node connected with the previous node, and as soon as we delete a node, okay, so then in this case, for instance, like what do we need to do? In 3 dot next equal to n5. If I do this way, then my program is fine. See, n3 dot next equal to n5. Okay, still. Okay. So if I do this way, so then I have to do some manual interaction, delete a node or insert a node, right? So, but what we want to do, we want to write a program, write another class or some other code so that our insertion and deletion or sorting can be automatic. Okay, so to do that, actually people usually what they do, people usually create a class named linked list. So since in Java I cannot have two public classes in a file, so I need to create another class without public, and for that class I want to name linked list. Okay, to create another class. Okay, so in order to automatic insertion and deletion, so in addition to my node class, this node class is done. Okay, I want to do in another class, I let it as a linked list class. And in this class, I will implement some methods that will help me to insert, delete, or search or sort. Okay. Slide. Now, if I go back to slide, so now everybody is familiar with this, how to create a node, right? Okay. Now, so here at the top one, that will be head, called head, and the last node that will be tail. Okay. But the tail node has no next. This is why next is null. So in pictorial description we say this deadline sign. In programming, we will say null. Okay, so you are familiar with this, and each of these is data. It says data and node. This is a node. This is a node. Okay. Okay. Now for insertion operation. For instance, I have a node with ID 7. Okay, and 5, then 8, and then 2, and 2 is the last node over here. Okay, so if I want to insert another node, new node 6, okay, there are two options that I can do, three options. I can add this 6 node at the top, you can make it a head, right? Or we can add it at the bottom, or we can add it middle, in between head and bottom, right? So if we want to add or insert a new node in our existing linked list, so if the linked list is empty, then what element we will insert, that will be the first element, right? There will be three situations, but think about situation starting with if my linked list is original linked list is empty, there is no element in it. Whatever element I will put, that will be the first element, right? That will be the top. That itself is top, that will be bottom. That is the first, that is the last, right? Then if I have already one element and if I want to add another element, then the question will come where I will put. I will add this at the front, or this will go on the top, or this will go in the front. Okay. If I want to add third node, then the more difficult question will arise. Whether the third node will go top or bottom or middle, right? Remember that we have to consider three cases for insertion. Okay, three maximum possible cases. Okay, and how many minutes I do have? Almost done. Time is over almost. Okay, so this my linked list class, it will contain what it will contain. It will contain a node, and we will give this node name as head or top. Okay, and it will have a constructor, and by default when you create the constructor, that by default it will make the head is null. Initially our empty will be, when you think about that, it will say if there is no node in a list, then it is empty, right? So the node will be, head will be null. So this is the startup of my linked list class. So okay, these are the required part. Okay, what we are going to do, we are going to write our methods, some method in order to do insertion, deletion, and sorting operation of our linked list. Whatever method we want to implement, all we want to implement in my linked list class. So this is the starting point I started with. Okay. Anyone has any questions so far? Okay, the next part I need let us check whether linked list, my list is empty. If I want to describe a method like this. For instance, I want to define a method. I want to check whether my list is empty or not. So by our definition, how do I say that a linked list is a list? If my head is null, right? If my head is null, then actually I can write this program like this way. If head equal to null, return true, else return false. Okay, so this is my isEmpty method. IsEmpty method is checking whether my linked list is empty or not. Okay, it's very simple, right? Is head equal to null, then return true. That means we are returning a Boolean value. And if head is equal to null, then return true. That means my linked list is empty. Otherwise, my linked list is not. Okay, so far whatever so by these two lines, sometime in programming when you will be, these two lines can be write as one single line like this. These two lines, this all of this line can be written only one line. It says return head equal null. That means if head is null, then it will return true, right? This value, this is a Boolean. This value will return either true or false, right? That means if it is true, then it will return true, right? If it is false, then it will return false. So these two lines, something you will see that this program code, whenever you will be skilled programmer, you will see this kind of code. Okay. Now whatever we do have, we have created a linked list class. Okay, and nothing in it, but for instance, whatever we have done, let us forget this. We will not use this code. We will not use this. Okay, for we will not use this. We are not doing any manual insertion or deletion. So that what we will do, we will use our linked list class. Okay, for instance, linked list ls1, we are creating an object equal to new linked list, and we will use this class in order to our automatic linked list. So now only at so far we have two methods over here, right? Actually link is empty method, right? Let's just check whether my linked list is empty or not. So if I print if I print ls1 dot is empty, what do we expect from output from here? Do we have any element in our linked list so far? No, I removed this. I don't need this. I do not have any code yet, any linked node yet. So it will show us false value. So if I see my false value over here, then I will be happy. Oh, sorry, is empty true. That means, I'm sorry, is empty true. That means empty, right? So then I'm happy that I created a linked list, but that is empty right now, right? Because I do not have any code yet. Okay, our time is over. So when we come back next week, next lecture, we will see how to add nodes, how to load automatically and how to remove, and then find search and sort. Okay, so actually we need one more full lecture to finish linked list. And once you give me 1 minute please, and once you understand list, so you will see that if you understand linked list, then stack and queue it will be simple. Okay, linked list is the foundation of all of this. Linked list, stack and queue. Please give attention, and whatever I discuss today, I will upload my video, but you can see my previous video, last year videos in my on my YouTube channel. Right? Thank you so much. Anyone has any question so far?